In this video, we are going to solve problem number 15 from the first homework of the fourth module. So we are told that there are two enzymatic reactions. So substrate S can either be converted into product P if we have enzyme A acting on it, or it can be converted to product Q if we have enzyme B acting on that. So for the first reaction, the Km is equal to 50 micromolar, and the maximum velocity is equal to 100 nanomolar over seconds. For the second enzymatic reaction, the Km is 5 millimolar, while the maximum velocity is 120 nanomolar over seconds. And the question is, if we have initial concentration or total concentration of substrate equal 100 micromolar, which product will be more abundant, Q or P? So we know that the change in product concentration over time is actually our velocity, right? So the higher is velocity, the more product is formed, right? So now this question transforms into just simply calculating the initial velocities for those two reactions. And initial velocity can be calculated using the Michaelis-Menten equation, which is the ratio of maximum velocity by the substrate concentration over the sum of Michaelis-Menten and the total substrate concentration. And so for A, the initial velocity will be equal to, for A, right, 100 nanomole over second multiplied by 100 micromolar concentration of the substrate and divided by 100 micromolar concentration, 100 micromolar for Km, oh, sorry, for substrate concentration, and 50 micromolar for Km, right? So as a result, I will have 1,000 here divided over 150, right? Sorry, 10,000. And I don't need to convert the units because here I have micromolar in the denominator. It cancels out with the units for concentration of the substrate, and so the rate will be in nanomolar over second. So if I use my calculator and calculate the values for the initial rate, it will be 66.7 nanomolar over seconds. So for B, the maximum rate is 120 nanomolar over second. The substrate concentration is the same, right? But the Km is 5 millimolar, which is the same as 5,000 micromolar, right? So here in my denominator, I will have 5,100 micromolar. And so this value will be equal to 2.35 nanomolar over seconds. So for product, for enzyme B, the rate of transformation of substrate S into product Q is much smaller than the velocity for the reaction catalyzed by A, right? So it means that product P will predominate, right? Of course, we can use Michaelis-Menten equation because we are given the time for the reaction, and it's very small, right? So we can use the initial velocity to determine which product will be formed will be more abundant.